Good afternoon or good day, ladies and gentlemen. Also from my side, a very warm welcome to the Frankenhalle here in Nuremberg. We have about 4,000 square meters of automation, electrification, and of course, digitalization. And that is something I will talk to you about for the next 12 minutes. If we look at digitalization, it's all around us. And I like to see it in this way, that digitalization is not a journey with an end station. It's actually about stepping on the train and continuously optimize whatever you're doing. The question is not whether or not digitalization will take place. The question is more like how or what will you do about with the opportunities that are hidden in the digitalization as a topic. When you came into the hall today, I hope you saw the nucleus of digitalization, the centerpiece here in the booth, where we have a very nice showcase showing how you can use popcorn or corn to make t-shirts. And on the other side, the car industry, how we as Siemens support the car industry with various types of technologies and surrounding technologies more or less. And that's what I will talk to you about today. I'm not going to talk about how you build or how you design and develop a car, more about everything around it. The company Bloomberg has come out with a report saying that 2018, 2% of all the cars, the new cars sold, were electrical cars driven by batteries. 2040, this will be somewhere around 54 to 57%. So definitely the car industry is going through changes. And if you look at it, if you have batteries, you will probably need to change the supply chain management, how you get the batteries to your factory, in what order and what time. And also the flexibility. If you consider that you are still producing cars with petrol engines, diesel engines, and battery engines, that needs different type of flexibility in the manufacturing environment. How do you solve that, for example? And that topic is something I will touch on also, this AGV, automated guided vehicles. And also technologies, which is totally cool, is additive manufacturing, how you are printing steel to build the most fantastic solutions and components, lightweight, but yet very strong. So those are the things. So let's step into the first scenario. So today, afternoon, you've been here in the Siemens hall for the whole day. You get on the bus, you drive down to the airport in Munich, A9. The bus driver is hammering down the Autobahn. And all of a sudden, he lets go of the steering wheel, he picks up his tablets and starts planning today's dinner. I think it's pizza or pasta, that's what I'm gonna do. At this particular point in time, I'm sure that you, and so will I, panic is the first thing. What's happening? He's not holding on to the steering wheel when he's driving there. But this is something that is not in a too far distant future. Basically, autonomous driving, cars or buses driving on their own. And you may think, why do you talk about that, Magnus? Well, the thing is, we at Siemens are also working in this field with technologies to make sure that cars are able to drive on the roads around the globe. To certify a vehicle for this type of driving, it requires somewhere between 13 billion and 33 billion kilometers. If you were to drive that on the roads, it would take you a fair amount of time. And this is where simulation comes into play. You build up scenarios in a digital environment. You use sensors and actors, making sure that your digital car, the digital twin of your car, is acting with the scenarios you're presenting for them. And that's kind of cool things. And this is something how we drive the development of the car industry. So continuously optimizing the setup and taking advantage of digitalization. If you move away from the street and we go into the production hall, many of you have probably visited car plants and you know that this type of layout, this environment is so optimized, it is so clean, it's so bright, it's just effectivity in a package. I'm sure you could eat food from the table, from the floor, it's so clean. So now if you take into the fact that you may have to integrate also battery assembly in this type of environment, that could be a challenge. So perhaps the complete concept needs to change. Perhaps you need to take into account AGVs, autonomous guided vehicles, in the facility. So if we were all here to order a car or define the car we would like, same brand, none of us would probably put together the same type of vehicle. Those AGVs enable this type of flexibility that, for example, your car will go to the station where you have the components that you have selected. The same goes for you, so the cars will be driving around. Obviously, this movie is more like a schematic view, or like a vision slide. But this is actually something we support also today with our simulation solutions. This is Technomatics plant simulation. a tool for optimizing the flow of material through a factory, optimizing the energy consumption. And we can also program those AGVs to work in this digital twin of a factory to see what roads they take and how they do their work fast and swift in order to make sure that the product you have ordered comes out. It may be a simulation, but this is also something that is used for real in many areas. And those AGVs are obviously equipped with Siemens components and enables this type of flexible manufacturing, making sure that we meet the market requirements when it comes to products. So simulation as such has a lot of benefits. You work in a digital environment, you simulate and you get validation, which are really a image or a mirror of reality, faster validation. You can test different what-if scenarios, scale it up, scale it down, see what money you can save or win. And of course also, if the demand is increasing or decreasing, you can adjust your production along those lines. That was my first use case for today. Now we're going to move into the machinery industry. One of our customers, Rosendal, an Austrian company, have been in the business of building machines for many, many years. They're extremely skilled at what they're doing, and they know the business from the beginning till the end. And they were working along those lines for 30 years and thought they did everything in the most optimal way. Then they started working with digitalization solutions, and in particular, the mechatronics concept designer, which enables you to connect the mechanics, the automation, and the electronics in one product. And using mechatronics concept designer, they reached new targets, new goals that they didn't think were possible. So basically taking into account those cross-discipline entities, having sure that the team is working closely together all in one package, working with the TIA portal, which you probably have seen here on the booth, working with PLC Sim Advanced, which is a virtual controller, and making sure that they validate the different concepts of a machine in the digital environment long before they even build a prototype. And this saved them a lot of time and a lot of money, obviously, in the long run. And one very prominent number is that it used to take about 2 years, 24 months, to develop a machine. And using digitalization, they actually put it down to 12 months. So that is definitely a good example of continuous optimization. The effect, as I said, yes, now 50% shorter development time, and they also managed to increase the efficiency rate of the machine itself and also the output of the same. Second industry ended. We're going to move now to a very, very cool industry. It's additive manufacturing, which, according to me, may actually be the coolest thing invented since sliced bread came to the market. If you look at this, if you would try to make a mold to create this type of burner head, it would be very difficult, probably also even impossible. But with 3D printing, you can actually do this. And build the most amazing models based on nature, for example. If you look at it closely, it actually looks like a fennel. You know what you get in fish soup from time to time, this very nice vegetable. That's kind of the idea. So taking nature's approach and designing products. However, there's still a lot of work that needs to be done in this. When you do this type of work, a lot of dust gets stuck in the model. Dust that has a potential, well, it can probably be potentially damaging for a human being. You don't want to breathe this in. You definitely want to reuse it, and you want to make it quick. In this case, you probably think, why don't you take that tray and just shake it around and the sand will fall out. Could do that, but if you have this fennel, it could be like this. When I was a kid in Sweden, quite a long time, many, many years ago, Saturdays were the day when you could go and buy sweets in the shop. And then you took your piggy bank and you shook it, and you're hoping that something would fall out. Sometimes it did, sometimes it didn't. I didn't know that there were algorithms at that time, but we at Siemens do have people that are extremely skilled in developing algorithms. So they took on this challenge. How can we make this even better, this process of taking the dust out of the printed parts? So they started thinking, playing with algorithms, and came up with the idea to, if we turn this in a particular order, then the sand will fall out. And the result is this: a machine which have been used for 3D printing, obviously equipped with Siemens components. I don't need to say that, but I say it anyway. This is vibrating, and it turns there's a pattern behind it, there's an algorithm that makes sure the sand falls out. And the longer you look at it, the more relaxed you will feel, because it's kind of a very relaxing feeling to it, how this flows out. And obviously, this is also a very good example of continuously optimizing a process. So, what benefits do you have? Surely, you will reduce the damage that could actually affect the human being. You don't have to breathe it in. There's no manual work needed. Reusing the power much more easily, and also no harm on the environment. So this is definitely something we're pushing. All those things I've been talking about now have something in common, and that is continuous optimization. And what makes this all possible, I'm sure you know it, it's actually to embrace digitalization. And that's something you can do in this hall. We at Siemens, we've been working on this progress or this approach for many, many years. Usually we go along a value chain, because every product, even this clicker, needs to go through the stage of product design, manufacturing planning, engineering, execution, and services. And when data is flowing back and forth and up and down, the digital twin comes to life. And I think I would say that we at Siemens are a company that master the digital twin top notch. We're very good at it. Because the vision to merge the virtual world with the real world has been ongoing for such a long time. And we have all the software and the hardware, and of course also the competencies to make this happen. And when they talk to each other, then those three twins come to life. The twin of the product, which is designing, optimizing, simulating a certain product. It could be a car, it could be a bus, it could be a clicker. Then the virtual product, building a digital twin of your facility, being able to work with this plant, optimizing, testing, and simulating. And then real production, automation, the TIA material, obviously also plays a very, very important role here, connecting the virtual with the real world. And when we're producing products, we're producing data that we collect and turn into information. We feed it back into the product development loop and the production development loop. So portfolio is there, but we also have the people, the consultants, the implementation specialists, and the optimizers, being able to support any industry on their journey to digitalization. So my call to action is keep on optimizing continuously, and I would really like to start your digital journey together with us.
Siemens, ingenuity for life.